Good afternoon once again. So today we're going to discuss this subject, data development analysis. So DEA, you have been exposed to an LP problem, linear programming problem. So DEA is an example, an application of linear programming. The what's the focus of DEA is to look at the efficiency of what we call DMUs. DMUs are decision-making units. So when we talk about decision-making units, it may be institutions that we're referring to institutions that make use of outputs and inputs. And I guess there's no company in the world that does not make use of any output that does not make use of any inputs and then generate outputs. So for example, if you're a manufacturing firm, the inputs can be your raw materials, labor, the outputs can be sales, can be finished goods. Okay? So those are examples of outputs and inputs. Now, in the case of DA, we can make use of multiple inputs and outputs. So this is a very powerful method. And Excel has the capability to do this. However, medyo limited yung capability of Excel to do DA is quite limited because there are nuances of this methodology which can be solved in Excel. Okay, so for example, for the DMUs, it can be business units, as I mentioned a while ago. It can be government agencies, even in educational institutions, and even people. Okay, people. So DEA has been used in assessing athletic performance, sales performance, and student performance. Okay, so what's the main objective of doing data and developmental analysis, or DEA? Okay, the main objective is to measure the relative efficiency of each of the DMUs being considered. Okay, so we're going to compute the efficiency of each of the DMUs, and it will be a relative efficiency metric. And we're going to determine which among the DMUs are relatively efficient. Okay, so that's the objective of this topic. You're given DMUs. You know their outputs, you know their inputs. So you compare. Use linear programming to determine which of these units are relatively efficient. So in DEA, okay, well, generally, how do we measure efficiency? Efficiency is measured using output over input, right? That's efficiency. However, in DEA, we have several outputs and several inputs. So what we need is what we do is to measure the sum. Okay, let me insert. Sum of symbol sigma. Okay, sum of, oops. Okay, we have here, this is the summation of the outputs, but the outputs are weighted. Okay, weighted outputs over weighted inputs. So this is how we measure efficiency as far as DEA is concerned. It's not the simple output over input, but it's a weighted output divided by the weighted input. Now, of course, based on this equation, we know that efficiency can be increased by, how may efficiency be increased? Just by looking at the equation, you increase the weighted output with the weighted input remaining constant. Or we decrease the weighted input with the remaining output remaining constant. Or another way to increase efficiency is to increase your weighted output and decrease your weighted input. So that's very self-explanatory. That's just algebraic. So you can increase efficiency by either increasing the numerator with the denominator remaining constant, or decrease the denominator with the numerator remaining constant, or increase numerator and decrease denominator. Okay, as I mentioned a while ago, in DEA context, efficiency is relative. Okay, so we're measuring relative efficiency, and the efficiency, okay, is measured by the weighted output over the weighted input. Okay, so we have this where W is the weight for the output and V is the weight for the input. Okay, so in order to make sure that we're able to optimize, okay, solve this using solver, there has to be a constraint. The constraint is that the efficiency should be bounded. So we will not make efficiency greater than 100%. Efficiency will be defined as less than or equal to 100%. If this is the case, then we can simplify this equation and then make it weighted output minus weighted input is equal to 0. Okay, I'm sure you're able to get this. Okay, so this is one of the constraints of DEA. The efficiency, the relative efficiency should be equal to, or this should be, sorry, this is wrong. This should be greater than or equal to 0. Right? Kasi ito greater than or equal to 1. So if we cross multiply summation of weighted input, then we put it on the other side, we transpose it. So it becomes, sorry. So this should be, sorry, 1, right? Am I correct? Yes. So cross multiply to 1. No. Because this becomes weighted input, and then we transpose this to the other side. All right, so this is correct already. Any question dito? Is it possible to have 100% where input is equal to output with no losses? Is it no, kasi ano to, no? Erwin, yung DEA relative efficiency to. So this is not absolute efficiency. So we're going to compare the weighted outputs and the weighted inputs of all the players of all the DMUs. Okay, so we're not talking here of absolute efficiency when a company will have 100%, no? Okay, so thank you for that question. In DEA sense, efficiency is construed to be relative efficiency. So we have a set of DMUs, decision-making units. We have their outputs, we have their inputs. So in the context of all of these DMUs, which companies are most efficient or relatively efficient compared to the others? Okay. So also, we're not able here in Excel, although there are other models now that are able to rank efficiency. In this case, in DEA context, we don't have ranking. We can only say that this company is efficient or not efficient. Okay. All right. So what are the components of a DEA analysis? As I mentioned a while ago, there should be inputs and outputs, and there should be certain principles in identifying inputs and outputs. To consider one variable as an output, we have to make sure of this. The greater the output, the greater that variable, the better. On the other hand, for inputs, the lesser, the better. Okay, so if you take a look at this, okay, so which of these are acceptable outputs for DEA? Net profit is okay because the larger the net profit, the better. Sales is also okay. Innovative products per month is okay. Satisfaction rating is okay. Cleanliness rating is okay. But the number of rejects per 1,000 is not okay. Okay, this cannot be an output because an output has to have this context. The higher the output, the better. But of course, number of rejects per 100, it cannot be considered as the higher the better. So if you want to have a DA output related to this, it should be number of good products or number of satisfactory products per 100. If that's the case, then that can be considered as an output. Okay. Now we know that for LP we have the three steps: no? The decision variables, objective function, and the constraints. So this in a nutshell is already the formulation for a DA. Okay, that's why it's quite easy relatively, because you know already what are the decision variables, what is the objective function, and what's the constraint. What are the constraints? So we take a look at this. What are the decision variables? Number of, this should be, so kindly change this is wrong. So it should be the weights of the outputs and the inputs. Okay, so those are the decision variables. We'd like to determine what are the weights here. So for the output, we have here W for the weight of the output and B for the weight of the input. So our decision variables will be the different weights for the outputs and the different weights for the inputs. And then the objective function will always be a maximization objective function. It will be to maximize the weighted output of the DMU being considered. Okay, we will impose the constraint that as far as the DMU being considered as our objective for our linear program, the weighted input should be equal to 1. This will make sure that the solution is bounded. Otherwise, if you don't impose that, then we might have there's a strong chance that the solution will be infeasible. Right? So how about the linear programming models? So this is something that's different for DA. Whereas in the other LPs that we have studied, we just have one, and we have only one LP. For DA, if you have 10 units, then you will have 10 LPs. You'll have 10 linear programs. Why? Because the objective function will always refer to one specific DMU. Okay? And since we have to get the DMU of all the weighted efficiency of all the DMUs, then as many DMUs that we have, as many linear program models. Okay, so if you have 12 DMUs being considered for your DA, then you should have 12 LPs, 12 linear programming models. All right. So for example, if there are 12 DMUs and we have 3 outputs and 2 inputs, how will the LP, when I say LP, it's linear program, be formulated for each? Okay, for each. So since we have 12 DMUs, then we will have 12 linear programs. Okay, so let's first take a look at DMU number 1 or unit number 1. What will be the decision variables for unit number 1? Okay, we said that the decision variables will be as many outputs and as many inputs. So since there are 3 outputs and 2 inputs, we have 3 W's and 2 V's, because W referred to the weight of the output and V refers to the weight of the input. Okay, so we'll have 5 decision variables. So if you have, let's say, 12 outputs and 10 inputs, then you will have 22 decision variables. Okay, then For the objective function, we will maximize the weighted output of unit number 1. Okay, and then for the constraints, there will be two parts. The first part is that we have to impose that the weighted input of the unit being considered should be equal to 1. Okay, this is what I was telling you all about a while ago. We will have to impose this so that the relative efficiency of the objective of the decision variable will be bounded. Okay, otherwise, as I said a while ago, if we don't impose this, then we might have infeasible solutions because our efficiencies will now be no longer be bound. Okay, so it's best to take a look at this via an example. So may I invite you to take a look at sample problem here? Okay, so this is our sample problem. Okay, even without the labeling, you would know which are the inputs and outputs here. So even the first step to doing a DEA is given your variables, you should know which are the inputs and which are the outputs. So profit, satisfaction, and cleanliness here are correctly classified as outputs, while labor hours and operating costs are labeled as inputs. Okay, for the outputs, the higher the better. So you should not have treated this as complaint rate. If, for example, the company has data also about complaint rates, then that cannot be an output. Rather, maybe a rate on the positive comments, maybe like that. So that can be an output because it's something that's the higher the better. Okay. For the inputs, it's the reverse. The lower the better. So technically, theoretically, the lower the labor hours, okay, assuming that production is not affected, then that's better. Operating costs, the lower the better, assuming that operations level will not deteriorate by reducing your labor hours and operating costs. Okay, so let's now write our LP. Okay, so let's first start with our decision variables. So what are our decision variables, class? What will be our decision variables here? It will be okay, and by the way, we are now creating the linear program for unit 1. Okay, so this is for unit 1. Okay, because there will be a different linear program for unit 2, a different linear program for unit 3 until unit number 12. So they will have each their own linear programs. Okay, so let's start first with the decision variable for unit 1. What are they?
Waits for the output of profit, satisfaction, and cleanliness, sir.
Okay.
And waits for the labor hours and the operation cost.
Yan. Oh, dito lang naman, di ba? Yan, no?
Yes, sir.
Yeah, so it's here, it's given. So the decision variables for unit number 1, this is unit number 1. You have 3 outputs. Okay. Although I should not have written the outputs here because we should know which of the variables should be an output or an input. So there's a weight for profit, a weight for satisfaction, and a weight for cleanliness. And there's also a weight for labor hours and a weight for operating cost. So this should be W1, W2, and W3, right? Okay, let me just put here V1 and V2. So these are the weights for profit, satisfaction, and cleanliness, respectively. And this is the weight for labor hours and operating costs, respectively. Okay? So that's about it. Just have to know how many outputs and how many inputs there are. So that will be our decision variable. And then we have our objective function. What will be our objective function?
Maximization.
Yeah, maximization of what? It has to be a function. What do we maximize?
Sir, the weighted output of unit 1,
Which is
which is W1 times profit plus W1 times satisfaction, W2 times satisfaction, and W3 times cleanliness,
which is
equal to the weighted output of unit 1.
so which is so we're asking here for the objective function. So ano yung objective function? So it is and one yung kanina binigay ni sino? Who was that? Sino yung sumagot kanina? Sorry.
Ako, sir. Erwin, sir.
Erwin, yung binigay ni Erwin, hindi yun yung equation, no? Ang tinatong natin, ano yung equation? Equation is, class? Okay, so this is our equation. So for unit number 1, the objective function is to maximize 5.98 times W1. This is the profit this is the profit value for unit number 1. So you multiply 5.98 by the weight, and then 7.7 by the weight, and then 92 times the weight. Okay? Right? So this is the weighted output for unit 1. Okay, so it's pretty straightforward. So we need an equation. And since we know the profit, satisfaction, cleanliness ratings of unit number 1, we can compute for its objective, for its weighted output, which is 5.98 times weight of 1 plus 7.7 times weight of 2 plus 92 times weight of W sub 3. All right, so let's now go to our constraints. What will be our constraints? So we have two sides to this, right? The first one is that for unit 1, its weighted input should be equal to 1. We have to put that constraint. Okay, so this constraint is that the weighted input of unit number 1 should be equal to 1. So based on this, let's take a look at the formulation here. Okay, so what would that be? Anyone? Okay, it will be, so 4.74 times B1 plus 6.75 times B2 should be equal to 1. All right. So this should be the weighted input for unit 1. Okay. So what else, class? What else is our constraint? If you take a look at our notes, ito, no? Weighted output minus weighted input. Okay, you recall this a while ago? Ito yung relative efficiency. Okay? Ito yung efficiency na dapat, this is the bounded efficiency. If you recall, I discussed it here, di ba? This one. The weighted output over the weighted input should be less than or equal to 1. So we're binding the relative efficiency. And this simplifies into this one. So this appears in our equation here. Okay, so the weighted output minus the weighted input should be equal to, okay, this should be less than or equal to, not equal to. Should be less than or equal to 0 because it's coming from here. The weighted output over the weighted input should be less than or equal to 100%. So when we simplify this, it becomes like this. So there's that less than or equal to. So less than or equal to. Okay, so let's set this up. So how many constraints as far as the bounded efficiency is concerned? Since there are, how many units do we have here? There are 12 units. Okay, therefore there should be
24 constraints.
24 constraints. Bakit?
Di ba sir, isa dun sa weighted input tapos yung isa pa yung dapat yung weighted input is minus weighted output minus weighted input equals
Yeah,
ayun,
so pero ima-minus lang siya.
Ayun nga. Bali,
So-
12 na
Oo,
Ay,
12, not
12
24.
times 2. Ay,
Bakit 12 times 2?
Kasi sir, dalawa yung constraint na dinivide natin, di ba sir? Yung
So,
sa
sorry.
baba. Yung sa baba, di ba sir, 2 parts. Sa letter C, ayan sir, di ba yung weighted output minus weighted input is less than or equal to 0.
Okay.
And then yung next line is weighted input is equal to 1. Hindi ba sila magkaiba sir?
This is only for the unit being considered. For unit 1 lang to, no? Okay, so dito sa constraint na to, and we have written this, di ba? Nasulatan natin tong tong constraint na to. This one is this one. This is the weighted input of unit 1 and it's being equated to 1. Okay? So ito yung yung constraint weighted input ng unit 1. Okay, in fact, tinignan natin to, no? Ito yun. 4.74 times V1 plus 6.75 times V2, okay, should be equal to 1. All right? So ito yung constraint natin for unit number 1 as regards the weighted input. And then paano yung itong portion na to, class? Di ba? This came from the fact that the weighted input cannot be greater than 1. Okay? And that's true for all the units. Kaya dapat ipe-perform natin to sa lahat ng 12 units. So, okay, so magiging ganito siya. Control C. Okay, take a look at this, class. Take a look at this equation. So the first part here is your weighted output. Diba? Ito yon, weighted output to. The second one is your weighted input. And we're subtracting the weighted output to the, we're subtracting the weighted output to the weighted input. And it should be greater than, less than or equal to 0. Ito yun. But that's only for unit 1. So we go to unit 2. So see unit 2, that will be 7.18 times W1 plus 9.7 times W2 plus 99 times W3. Okay. Let me. Okay, so 7.18 W1 Okay. All right. So this is now. Okay, what's this now? This is now actually your bounded efficiency or relative efficiency for, this is for unit 2, unit 1. This is the bounded or relative efficiency for unit 2. Okay, and then you will have to do it for all the 12 units. Okay, because we have to impose that each of these units cannot have an efficiency of more than 100%. Okay, so this equation, just by way of review, came from the fact that your, let's go back here, weighted output over your weighted input, okay, should be less than or equal to 1. So this is an imposition that there can not be any relative efficiency that's greater than 100%. Okay, so as I said, the simplification of this concept of this let me call it, what's a good word for that? Okay, of this imposition that the efficiency should not be greater than 1. Okay, the simplification of that is this one. Okay, so they are equivalent, pareho lang to. No? So summation of weighted output minus the summation of weighted input should be less than or equal to 0. Okay, so and all the way down to, let me just to, all right, so that will be until okay, so this becomes 8.35 and 9.6 and then 97 and then 6.58 and then 8.75. Okay. 8.75, 6.58, 97, 9.6. Okay. Clear, class? Clear? So there should be 12 constraints like this, and one constraint for, okay, for this one, that the weighted efficiency for unit number 1 should be equal to 1. This is the weighted efficiency for unit 1. Okay, V1, V2. Okay, so let me pause for a while. Any questions? I'll give you, if you want to complete that, I'll give you a few seconds. All right, so let me pause for, let me stop recording first. Pause recording. So we have identified our decision variables, our objective function, and our constraints. Now we're ready to solve this. Si kompleto na yan natin. Of course, ano nga pala, no? W1, in our case, W1, W2, W3, V1, V2 are all so this is our non-negativity. Okay. So we will now solve this. Okay, take note that the decision variables are 5, W1, W2, W3, V1, V2, and then we have the objective function, which is the weighted output for unit number 1. And then we have the constraints, which is that the bounded, these are the bounded efficiencies for all the units, which is just the same as weighted output minus weighted input divided by the weighted input should be less than or equal to 1. Okay, so let's now solve this. Okay, any suggestion where to put our decision variables? Okay, why don't we do this again? I'll give you okay, sige, we'll break ourselves into groups, no? Just sit work lang, hindi naman graded. I just want to see how you'll solve this. Okay, sige yung ano na lang, yung grouping natin. So, yung group 1 and 2. So I'll open 9 groups now in Canvas, in Zoom, and then go to that group and solve, model that one. And then I'll request you to share to the plenary the model that you arrived at. Okay, so let's see. Let's create breakout rooms. The 9 that participants choose. Okay, so kindly enter your respective breakout room. I'll give you 5 minutes to come up with a model, and then I'll request you to share your answer very quickly. I'll request you to just show the model that you arrived at. All right, kindly please go now to your respective groups based on our grouping. By the way, may I request Jason and Christine to occupy group 7, Tapos si Ray at saka si Rosel, group number 8. Alright, so I changed the grouping kasi empty yung group 7. Okay, ups, open all rooms. Alright, so I now open the breakout session, only for 5 minutes to class, no? 5 to 10 minutes. And then I'll ask you, the groups, to show your answers in class. O share muna ako, ha? Please remind me. Okay, so thank you very much, everyone. Now, in the interest of time, I noticed that most of you got it. Only that some of you did it differently, but that's okay. It's not how it's. You can do it, of course, in different ways. This can be solved in different ways, but there are efficient ways to do it, and there are, let's say, not so efficient ways to do it. Okay, so let's discuss one way of doing this. Okay, so taking a look at our equation, we need to set up our decision variables, and we will need to multiply our weights with the factors of output factors and input factors, right? So our output factors are here, and inputs are here. So I guess the best way to set up your weights will be in parallel to your outputs and inputs. Okay, so let me just put it here. Some of you did it the reverse, but that's okay. But I guess this will be a better way to present your. So let me put borders here and then fill. Okay, so this will be our decision variables. And the reason why I place it in this manner, you could of course place it above, but it would have been best had we positioned our weights in parallel to your outputs and inputs, so that, for example, if you're getting the weighted output for unit 1, it will just be okay. It will just be the okay. So let's put here the weighted output because we need this, and we also need the weighted input. Okay, so what will be our weighted input and weighted output? So also it's good to take advantage of the structure of your data. So our weighted output will simply be, what will be the formula here? Let me just increase the size. What will be our formula here, class? Knowing this,
Some product.
yes, it will be some product, no?
Yeah.
Some product. Okay, I saw some of you. You did set up your model this way, but you multiplied it individually. So that can make it quite long. But of course, you can do the cell referencing. But it's good also to use the functionalities of Excel. So some product of our factors, our input, outputs, multiplied by our weights. Okay. Okay. In fact, we could do this. We can name this as output weights, and this one as our input weights. Okay, so that our equation will be the sum product of our outputs multiplied by the output weights there. Okay, Control Enter, and then our weighted input will be the sum product also of our inputs and the input weights there. And we can just copy this down, or this is the field handle there. Okay, so we now have the weighted output and the weighted input of each of the units. If we take a look at our model, so we now have this V's. We actually have already our objective function for unit 1. That's the that's the weighted output for unit 1, which is this one, right? It's this one. That's a weighted output for unit 1. And then also the constraint for unit 1, which is the weighted input, which is this one. So this is the weighted input for unit 1. This is the weighted output for unit 1. And then we need to get the difference between the weighted output and the weighted input. Okay, so this would be equal to, let's make this as the difference. Okay, which is our weighted output minus weighted input. Okay. All right, now I saw some of you having a different setup. It's okay. It's okay. But maybe as a suggestion, try to make your model in such a way that it's efficiently constructed. Okay. So this will be our constraint. Okay, and then what will be our, we have our decision variables. We have our objective function. What's our objective function? The weighted output for unit number 1. It's this one, right? This is our weighted output for unit 1. This is our objective function. Okay, so once again, let's take a look at this model. This is our decision variables. Decision variables. Then objective function. It's this one. Okay, and then we have this one as our constraint. Sorry, this one. This is also a constraint. $4.74 times V1 plus 6.75 times V2. This is that formula, and it should be equal to 1. So it's part of the constraint. And then the differences between your weighted output and your weighted input is this one. Okay, so it's precise. It's efficiently done. So you make use of the structure of our data. And therefore, our solver will be data solver. All right, our objective function will be this one. It's a weighted output for unit 1. Remember we're modeling unit 1 here. Okay, and then it's a maximization problem. By changing variable cells, what are our variable cells? This one. Okay, and then subject to what constraint? So let's add our constraints. The weighted input for the unit in consideration should be equal to 1. All right, and then add the differences should be less than or equal to 0. Okay, so this is our model class. maximize our weighted output. Our weighted input for the unit in consideration is this one. All right. And then the difference should be less than or equal to 0. Okay, since this is linear, I can put here simplex LP. And then make unconstrained variables non-negative. These are non-negativity. All right, and then solve. Solver found a solution. Okay. All right. So question, what is the efficiency of unit 1? What is the efficiency of unit 1? Anyone, please?
97%.
Yes, 97%, correct. Why? This is the weighted output, and we impose that the weighted input of unit 1 should be 1. Okay, so this is a constraint. So the efficiency of unit 1 is the weighted output over the weighted input. Okay, so I can now put here 0.9667. Okay, I cannot link it here because we're going to use this again for the next one. Okay, the efficiency of unit 1, I cannot link it to this cell because this will still change. So I just typed it 9.667. Okay, so how do we now compute for the efficiency of unit number 2? Okay, once again, please. Okay, I'll give you time to work on your model, build it this way. Okay, by the way, the weights here do not actually have a practical meaning. The weights are used so that we're able to maximize the weighted output. Okay, so it's not something that you interpret. So it's like a tool that's used in order to maximize our, let me just fix the, okay, just make it 3 decimal places. Okay, and it's not going to be 100%. You might think, but why is the weights for profit satisfaction and cleanliness not equal to 100%? Because what's happening is that Excel is looking for the combination of weights for your profits and the combination of weights for your outputs, and the combination of weights for your inputs. And they should be non-negative so that you're maximizing the efficiency of that unit. In this case, this is the combination of weights for the outputs and weights for the inputs that will maximize the efficiency of unit 1. So unit 1 is efficiency is 0.9667. Okay? All right, I'll give you time to, you can create this model in your case. And once you have finished it, class, I would want to again request you to chat so that I know if you're done, because some of you had a different model, but it's correct. You were able to capture the decision variables, objective function, and the constraints. However, shall we say it was it could have been better. Okay, it could have been more efficient. Okay, so I'll wait for your response. Okay, may I know what's the efficiency of unit number 2? Could you dictate, please? What's the efficiency of unit number 2?
0.958.
0.958. Okay. How about unit number 3?
0.8177.
Okay. Point
818.
77. Okay, let's put it to 4 decimal places. And next is unit number 4.
1.
1. Number 5.
0.8237.
0.8237. Number 6.
0.7975.
7975. Okay, thank you. Number 7.
1.
1. Number 8.
0.7514.
7514. Number 9,
0.8053.
8053.
Opo.
Number 10,
0.7768.
7768. 11,
89.8941.
8941,
1.
and 1. Okay, so let me just run through, let's see model unit number 2. Okay, so we now have, let me go to solver again. Data, solver. Okay, I'm going to do number 2. So I'll just change the objective to this one. That will be our weighted output. Maximize, changing cells will be the same. And then I'll change this to this one. The weighted input of unit 2 should be equal to 1. Okay? So that will be the constraints for the objective function, the changing cells, J17, H17. Okay, this is the same. All right, solve. And solver says, one. One dapat to. Bakit naging 0.9580 yung ano mo? Number 2 should be 1. Where did you get 9580? Okay, thank you, Erwin. Saan nakuha tong 0.9580 nito? It should be 1, no? Let me see. Baka hindi nyo sinolve, ah.
Baka na
Solver.
manual, sir.
Ah?
Baka na manual.
Hindi, let's see. This is H16. Change natin to I16. Okay. Solve. Saan ang galing tong 9580?
Sa unang solution yata yan, sir. Naka-manual. Hindi ba?
Pero wala eh. Hinanap ko yung 9580. Wala dito. I thought that
Output divided by input yata yan, sir.
output over input. Okay. Doon kinuha, no? Dinivide siya. Okay. All right. So, pero hindi yun class, no? This is not the efficiency of unit number 2. Kasi for unit number 2, you have to do the solver. Magsi-solver tayo. So, babalikan natin yung yung data natin. Data, solver. So, for unit number 2, our objective function will now be the weighted efficiency of unit number 2. Ito na siya. Maximize pa rin, changing cells pareho pa rin, this one. And then, ang constraint natin should be the weighted input of unit number 2. Number 2, no? Should be equal to 1. Okay. Tapos, ito, pareho pa rin, no? The difference, all the difference should be less than or equal to 0. So, if we solve this, solver found a solution. Okay. Weighted output of unit number 1 is 1. So this should be 1. Okay? So, kurang ko lang to dito, ah. Okay. How about unit number 3? Ganun pa rin. So we will have to repeat the process. This time, this will be the objective function because we're dealing now with unit number 3. Okay, same changing cells, and then our constraints will change. It will be the weighted input of unit number 3. We're now doing the DA for unit number 3. Okay, and then same thing, same pa rin yung ano, yung difference, less than or equal to 0. Solve. Okay, solver found the solution. Okay, therefore, the efficiency of unit number 3 is 0.8345. 0.8345. So 0.8345 si unit number 3, no? Si unit number 4, a comment. Okay. So sige, thank you Thank you for this. Erwin, 96.67, 100%, 83.45. So this is 100%. 83.86. Paki-check nga class please kung pareho tayo ng sagot ni kay Erwin. 83.86 and then 82.53. Then unit number 7 is 1. Unit number 8 is 77.20. Unit number 9 is 85.72. Unit number 10 is 79.57. 11 is ano to, 91? Erwin?
Yes, sir. 0.9188.
Nagkarugtong pa yung unit 11. Kala ko 191%. 0.9188 and then 100%.
Yes, sir.
Thank you, Erwin. Okay. All right, class. So this is the efficiency. Paki-validate nga, paki-check. Okay, for example, itong unit number 6, is it 1? Is it 100%? Is unit number 6, unit number 7, 100%? Ibigay kay Earl, unit number 7, Earl?
Yes, sir. Parang nagkatalo namin sa weight 3. Parang sa akin 0.0007.
Sa weights, pwedeng may alternative
pwede
solution na. Basta ang importante, efficiency, dapat pare-pareho tayo. So ang efficiency ba ano yung efficiency ni number 7?
7 ko is 1.
1, okay, tama, no? Pareho. So how about number 6?
8258.
8258. So, sige, check natin Baka ako nagkamali sa pagsulat. 8253, 8258. So may discrepancy ng decimals. Kaya check nga natin.
Mine is also 8258. Pero my 7 is different.
Oh, okay. So, i-validate yung class yung mga make sure na tama yung sa solver, no? But we're going to learn, di na natin aabutin yun. We're going to learn next meeting a better way to solve this kasi ito manual pa rin eh. What if we have, let's say 50? What if we have 50 DMUs? Although sa Excel, I'm not sure kung ilan yung limit. May limit sila eh. Ilang ano ba? Hindi ko lang maalala kung 40 or basta may limit sila ng DMUs. But other softwares, of course, can accommodate even more than hundreds of DMUs. Okay, so assuming that this is correct, okay, we can now conclude that model unit 2, unit 4, unit 7, and unit 12. Okay, they're the efficient units. They are the DEA efficient units. So which means that they're able to make use of their outputs. They're able to generate their outputs, okay, more outputs than their non-efficient counterparts, okay, given the same level of inputs. Or they're able to generate the same level of outputs given a lower level of inputs, okay, or they're able to generate more outputs given lower inputs. The three situations we mentioned a while ago. Okay, so can we prove that? Yes, we can prove that. Huh? Sige, i-prove natin yung tingnan natin kung how that happened. No? Okay, so let's solve, let's say, unit number 5. I'm going to solve unit number 5. So data, solver. Okay, then unit number 5 is this one, H20. So this will be change. This will be I20. There. I20 should be equal to 1. Okay. H20 maximize I20. All right. So solve. Okay. Solver found a solution. Let me check first. Number 5, 0.8426. Iba.
Same, sir, sa akin po.
Same din, sir, sa akin.
Eight. 8426. Okay, sige. Erwin, check mo na lang yung yung model mo. No? 8426. Now I'll do the sensitivity analysis. Okay, I'll just generate the sensitivity analysis. Okay. Okay, so ito, sensitivity analysis. No? All right, and I'll be needing the shadow price. This one. So this one's sa difference, na hindi sa input. This one. I'll be needing this. So Control C, let me copy that, and then let me go to the model itself, and then let me paste it here. Tingin ko lang ng konting ano. Kasi laki masyado ng decimal. Okay. All right. So this is the shadow price for unit 5, right? Okay. Okay, so the efficient units among the 12 DMUs are unit number 2, assuming this is correct, no? Assuming this is correct. Units number 2, units number 4, units number 7, unit number 12. Okay, let me conditional formatting ko nga. Okay. So ito yung mga ano natin, no? Yung mga efficient units. Equal to 1 yung efficiency nila. 1, 1, 1, 1. So apat. Okay, and this is the shadow price for unit number 5. Okay, so what does this mean? What does this mean? It means that you can create, just like a Frankenstein object, no? Yung Frankenstein object, di ba, you know the story? This created individual had body parts that came from different individuals. Okay? So ito, ang sinasabi sa atin ito, we can generate a Frankenstein object. Lagay lang natin, conditional formatting ko ulit. Okay. So we can create a linear combination of your efficient units that performs better than your non-efficient unit. Ulitin ko. We can come up with a linear combination of the efficient units. Okay, thank you, Erwin. That performs better than your non-efficient unit. So what does this tell us? It tells us that we can combine 9.3% of Unit 2 and 94% of Unit 7. The sum might, hindi pala 9%. Tama, 9%, 94%. So a little above 100%. No? But it's a linear combination of unit number 7 and unit number 2. Okay, 9% in unit number 2 and 94% in unit number 7. And this linear combination or this Frankenstein unit will perform better than unit number 5. Kasi ito yung shadow price ni unit number 5. Okay, so how do we show that? How do we show that? Okay, so i-compute natin yung yung profit satisfaction, cleanliness, labor hours, operating cost ng Frankenstein unit natin. Okay? So let me do that here. So this is for unit 5. Okay? Yung linear combination mas magaling pa kay unit 5. So this will just be final natin font. So this is equal to the sum product. Sum product natin. Sum product of, kunin natin yung profit, no? Itong profit matrix natin, profit array, sum product nito with this one. Okay? And if you notice, only the ones with non-zeros will enter the picture, the profit picture. Kasi the others are zero eh. So ang magbibigay lang ng contribution sa profit will be 9.3% ni unit 2 at saka 94% ni unit number 7, which are linear combinations of your efficient units. F4. Okay, ilat natin to. Since we're going to copy the formula to the right, so no need to fix the row 16 and row 17. Okay, mali. Yan. So if i-fix na natin si column L, okay, ito. Okay, Control Enter. Okay, and then I copy this to the right. Okay. So let's compare this with unit number 5. No? So itong Frankenstein unit na to, consisting of 9.3% the unit number 2 at saka 94% the unit number 7, okay, has a profit of 3.39. So pareho lang siya ng profit ni ni unit number 5, di ba? Pareho lang. Okay, pero okay, what's this? In terms of satisfaction, si unit number 5, and so ito yung Frankenstein unit, it outperforms unit number 5 in terms of satisfaction. 7.8 lang yung average ni 5. 9 yung average nitong linear combination ng unit number 2. Dapat to unit number 2 plus 7. Okay, so linear combination yan, 2 and 7. So higher yung satisfaction, pareho yung cleanliness. Labor hours, okay, take note, 3.45 dito kay number 5, 2.82 lang to. See, 4.43 dito, and then 3.73 dito. So its input levels are lower than that of unit number 5, and its output levels, at least some of them, for example, satisfaction is higher than that of unit number 5. Okay? So indeed, unit number 5 is not significant, and since unit number 2 and number 7 were chosen to be part of this linear combination that's better than unit number 5, then we are assured that indeed units number 2 and 7 are efficient, no? Kasi only those that are efficient can form part of the linear combination that's better than the non-efficient units. Okay? Any questions so far, class? Sige, I'll give you a few seconds to work on that. Okay, try it with unit number 3, for example. What linear combination of efficient units will perform better than unit number 3? Anyone? Linear combination ni number 3, unit number 3. A linear combination of the efficient units that performs better than unit number 3. Since unit number 3 is not efficient. What do you get? So waiting for your response, class. Pause ko lang yung share. Yung recording, just in case you were not able to follow along. So we go to data and then solver. Solver. So we're solving here unit number 3. Unit number 3, the weighted output is this one, H18. And so this should be I18. I18. Okay. I18. Okay, so we solve it, and then we access the sensitivity report. Okay. And then a sensitivity report is generated. So we go to the shadow price, this one. Ay, sabi na ano ko. Bakit 100%? If you see that the shadow price are all zeros, that means, class, that you were doing a sensitivity analysis for an efficient an efficient AN, no? An efficient unit. Okay, what did I set now? Let me check. Did I use 18? Yeah, I think we use unit 3, right? And unit 3 is not efficient. Okay, let me see. Let me redo the process. Data solver. Our objective is
Same yung constraint sa objective yan.
okay, I made a mistake here. Okay, it should be okay. H18, yeah. Okay. And then this is I18. All right, maximize. All right, so I made a mistake in clicking the objective. I accidentally clicked it to be the weighted input. It should be the weighted output. Solve, and then click the sensitivity analysis, and then okay. And then if we open the sensitivity report, this one, number 3, we have this. Then we get, for the shadow price, around 33% of unit number 2, 62% of unit number 7, and around 10% of unit number 12. If I copy this, copy it here, all right, so this is for unit number 3. Okay, so you have 32% of unit number 2, 62% of unit number 7, and 9% of unit number 12. And let me just do conditional formatting. Okay, there. Okay, and then once again, if we compute for the outputs and the inputs, so you have here sum product. Let's just validate this sum product of your profit and your linear combination. F4, F4, F4. Control Enter. Okay, so if we take a look at this, in terms of, we have to compare it with unit number 3. In terms of profit, they're the same. In terms of satisfaction rating, this unit, combination unit, is better. In terms of cleanliness, they're the same. However, in terms of labor hours, this is 4.21 as compared to 5.04. And in terms of operating costs, this is 5.3 compared to 6.35. So we were able to show that indeed unit number, a linear combination of unit 2, 7, and 12, given that weight, those weights, okay, is better than unit number 3. And you can do the same for the others. And if you try to get the shadow price of an efficient unit, you will get 0. Okay, you'll get 0 shadow price. For example, you resolve unit number 12, get the sensitivity analysis, and then get the shadow price of unit number 12, then you get 0. Because there's no other linear combination of the efficient units that's better than unit number 12. Because unit number 12 is also efficient. Okay? Let me pause for a while. Is that clear so far, class? Is that clear? Okay. All right. So what we have done so far is to compute for the efficiency. But you know, if we have 50 units and then if we keep on changing the solver, that would be really be time consuming. Okay. So let's do something so that we can at least a bit make our process more efficient. Okay, so let's use, I don't know if you have used the index function. Let me state here unit. Okay, and then let me identify the output and then the input. So what we can do is we will just have a link here for the output and the input. Okay, we will have a link here for the output and the input, and then we'll just state what unit it is. Okay, so for example, this is unit number 1, right? How do we pick up the output of unit number 1? Okay, we need to get the output of unit number 1, which is this one, right? The weighted output of unit number 1 when we solve for unit number 1. And we also need to get the output, the input of unit number 1 when we're solving for unit number 1, because we need that, right? Okay. So how will this formula look like? So there's a function called index. Okay, let's use the index function is equal to index. Index returns a value or reference of the cells at the intersection of a particular row and column. Okay? So I'm going to use, for example, for the output, I'm going to use this row, okay, and then intersect it with the row that's written here. So if this is written as 1, then the index will give us in this row, in this column, row number 1, which is this one. Okay. If I write here 2, then it will give us the value of the second row here. Okay, let's try that. So index, okay, what's our array? What array are we going to look at? Saan natin hahanapin? Where are we going to look for the weighted output? It's here, right? We're going to look for our weighted output there. Okay? And then, what's required?
Unit.
Yes. Okay, comma. All right. What row number? We highlighted this column So we're asking Excel to look for this particular row. Okay, and then comma. Notice that the column is optional. Kasi isa lang yung highlight natin. Since we only highlighted one column, then the column number here becomes irrelevant. But still, you can put here column number 1. Okay, and as I said, you notice that the formula here is written in brackets, which means that that's optional. You may or may not put a number there. If I don't put a number, Excel will read that to be 1 because there's only one column. Okay, so let's do that. Control and enter. And then I'm getting a 1.991 because currently, okay, this is 0.991. If I change this to 5, it will fetch, okay, this became 0.583. All right. So it's here, there, 0.583. 1, 2, 3, 4, 5.
Sir,
Okay. Yes.
okay lang din po ba pag VLOOKUP dyan?
VLOOKUP. VLOOKUP.
Since may
VLOOKUP.
number sa gilid.
Uh,
VLOOKUP 1.
Tingnan natin sige is equal to VLOOKUP. Hindi ko pa nasubukan ng VLOOKUP dito eh. So, ano yung lookup value
C34.
natin?
C34.
Okay, sige, tingnan natin I think pwede rin, no? VLOOKUP,
C34.
lookup value is this one, and then comma.
B to H.
Kaso, saan niya hahanapin?
B to H,
dito.
sir. Yes, sir. Tapos,
Ano, no? T to H?
E16. Ay, yung
B?
column, yung table,
This
sir.
one?
Yes, sir. Hanggang output.
Yung buong, ito, i-highlight.
Yes, sir.
Yun disadvantage kasi masyado nang malaki yung iaan natin. Isasama mo na to.
Pwede yung sa column yata, sir, sa taas, yung B mismo. Yung
Saan?
column yung highlight mismo.
Hindi, sige. Sige, ikaw mag-share ng para ikaw gumawa, no? Sige.
Hindi ko pa na-format ng ganyan,
Pero
sir.
sige.
Sir, I think you can, highlight lang yung
Yung
table. It's fine.
Which one?
B,
Ito?
yeah, B15 to 27.
No, pero saan niya hahanapin yung value? Di ba dito niya kukunin eh?
Yes, sir.
Yes, sir.
So
B
you have to
H.
highlight
B-
everything.
Yung table lang, sir.
Kaya nga, you have to highlight everything. Isasama mo dapat to.
Yes.
Yes, sir.
That makes it really a more kasi yung buong table na ang aanin natin eh, di ba? In fact, mas maganda X lookup ka na, no? Kasi X lookup pwedeng ito lang at saka ito, no? X lookup, that's if you're using Excel 365, no? So pag VLOOKUP kasi I will have to also parang napaka-complicate pa kasi isasama natin yung buong no? Yung buong table na to. But that's okay. You can solve for that, no? Pwede rin naman mahanap siya, makukuha din. You'll get also the same answer. But yung index is very simple lang. Kasi ito lang yung hina-highlight natin. Diba? Hahanapin mo lang naman dito yung output. You're just going to look for the output here. And then you'll just have to tell Excel, what row are you looking at? Okay? Well, in effect, it's the same as the VLOOKUP. But for me, okay, why bother yourself getting the whole table? No? So this becomes extraneous data, extraneous information. So sa input then, you're going to highlight naman, so you'll be including also the input here. When in fact, you can just use the index function here also. Okay? So I'm not saying that you won't get the correct answer. You will get the correct answer. Okay. However, it's more complicated, and I would say that it's not an efficient way to get your value. If you can just use one column instead of using 6 or 7 columns, right? Diba? Do you agree, class? But you'll get the same answer, no? VLOOKUP. So if for example, if I write here VLOOKUP, okay, dito, here, is equal to VLOOKUP. And by the way, nowadays, it's better to use the XLOOKUP Kasi in VLOOKUP, your data has to be arranged in such a way that the reference should be at the leftmost. In XLOOKUP, the reference can be anywhere. Okay, and you don't have to highlight a table. You just have to highlight columns. All right, so VLOOKUP, our lookup value is 5. Okay, and then we're going to look it up in our table array. This is our table array here. Okay, and then index is 1, 2, 3, 4, 5, 6, 7. That will be the 7. Yeah, 7. 7, and then it should be the true exact match, so this should be false or 0. You can type false there or 0, and you'll get the same answer. So it should be 0.580 also. Okay, but in terms of efficiency, in terms of let's say more simple formula, of course, okay, tapos marami ka pang dito, i-highlight, okay, this is a lot better, si index. Kasi isa lang yung i-highlight natin. And when we go to the input, okay, same thing is equal to index. This time, the array that you're going to highlight is the weighted input there. Okay? And then comma, row number, we'll refer it here. And then, okay, so since we're only dealing with just one. Okay, and we'll get 0.696. So let's see, if it's 0.696, number 5, 0.696. So if I change this to number 12, then it will fetch the outputs and the inputs for row number 12, 1367, 1367. So what's the advantage here? The advantage here is that you don't, in your solver, you will not keep on changing your objective function and your constraint. So let me illustrate that. Data, okay, data, and then solver. So let's change now our parameters. Our objective will be just here. Okay, just here. And then same maximization, same changing cells. And then this one, let's change this. We will just refer it to our input here. There. Okay, it's equal to 1. Okay. All right. So now we are at unit 12. We are solving unit 12, right? Solve. Okay, we have the solution. Unit 12 is 100%. Okay, so I write here 100%. All right, so if you're going to solve now for unit number 1, just put here 1, okay, and then go to solver, data, solver, and then you don't have to change anything here. Okay, unlike before, you have to change this and then you have to change this. All right, you don't have to change anything here because everything has already been set so that we'll get an output. We have already defined our weighted output and weighted input based on the unit number. Okay, solve. Then we get now, solver found a solution, and it fetches here. The weighted output, the efficiency is 0.967. Okay, and the input, of course, since we made this equal to 1. All right, then number 2 again. Number 2, so you go to solver, data, solver. Again, you won't have to change anything here, just solve. All right, so unit number 2 is efficient, 100%. All right, so this is a lot better than the previous one. Okay, but the next meeting we're going to show, because I'll be needing more time for that, will be, I'll be showing you another method so that just one click, then everything will be reflected already. Okay, so the first one was a bit manual, where we had to change the solver parameters one at a time, okay, the objective function and the constraint to get the efficiency of that specific unit. Okay, and then we copied it here, right? Now for this one, this is a better solution. Of course, you can use the index function, or VLOOKUP, but it's better even to use the XLOOKUP. Kasi XLOOKUP, it's for 365. It doesn't exist sa ano no sa 2016. Lookup value, lookup array, return array. Ganun lang, no? Lookup value, what's your lookup value? This is our lookup value. Okay, where's our lookup array and return array? So let's try that. Lookup value is 2, comma. What's our lookup array? Our lookup array is this one. Okay, so you don't have to highlight everything, because in VLOOKUP you have to highlight up to the point where you get your output. Here it doesn't matter. So that's why this one can be at the end. No problem. In VLOOKUP, the index should be on the leftmost. Otherwise, it will not work. Okay, and then, comma, what's our return array? This one. Okay, that's it. I didn't have to highlight everything there. Okay, close, enter. Okay, still 1. Okay, so this is my weighted output, right? Okay, if I make it 3, okay, I'm getting the same answer, right? So it means that our formula is working. This is the index, this is the VLOOKUP, and this is the XLOOKUP. Okay, so for me, if ever lookup ang gagamitin, I'm going to use the XLOOKUP kasi mas ano siya, mas simple talaga siya. Okay, all right. So welcome now to the world of let's say changes which Excel is doing. Okay. All right. Any questions, class? Any questions? So given certain units, certain DMUs, and then given your outputs and inputs, you can determine which of the units are efficient based on DEA, which are not non-efficient. So what's the use of this? What's a practical use of this model? Well, do banks use this? Definitely. Do manufacturing companies? Yes. Okay, of course, they're going to compare themselves with their peers or with their industry competitors, especially sa banks. I've done some already some students of mine in the past. I have advised them on this as their advisor. So nagdi-DEA kami, but of course we're using a different software and not Excel kasi mas powerful. Kunyari R, we're using R in order to come up with a data and developmental analysis using R or Python kasi mas powerful yung mga softwares na yun. But R has its use also. So for just to determine which are the efficient units and which are the inefficient units, then R will suffice. Sorry, Excel will suffice. Okay. Any questions so far, class? Any questions so far? Okay, let me reword my question. Is it clear so far? Yes or no, please? Okay, thank you. Thank you. Good. Okay, yung iba. Yeah, okay. Yeah, thank you. Yeah, yung mga models na ganito, class, usually we don't learn it in one sitting. No? Yeah, and it's good to review what we have done and to gain some mastery of the subject. Okay, so next meeting, yeah, thank you. Thank you for your comments. Next meeting, we will leave something here for discussion next meeting kasi kukulangan na tayo ng time. So let me go to another model. Let me illustrate that model. So kindly go to our canvas and I uploaded there another file. So let's go there, please. Network modeling, let's go there. Okay, hindi ko na i-download. Meron na copy niyan. Okay, I'll just introduce the concepts here. Okay, so network modeling. This is the last LP model that we're going to discuss. And the next meeting, we will also go into nonlinear programming. All right. So network modeling is a family of problems where models can be represented by networks. So a family of nodes and arcs. So this is a representation of, you have here your nodes, and the lines are your arcs. So this represents a flow of goods. Okay, the red figures here represent the supply or demand of each node. So for example, Newark here, negative 2000, which means this is a supply node. Okay, negative there means it can put out, it can bring out, it can deliver 2000. Boston is a demand node, okay, plus 1000. So all the pluses here are demand nodes. All the negatives here are supply nodes. Okay, so the question is, you have the supply of 200, negative 200, negative 3000, 2000, 3000, that's 5000. And we want our system, our network, to deliver, okay, to deliver to the different nodes. And the nodes here represent the cities. So Richmond needs 800, Boston needs 1000, so that's 1800, Columbus 600, so that's 24, Atlanta 17, so that's 41, and then Mobile is 700, so that's 48. So which means that our supply exceed the demand. Okay, for 5,000 the supply is 5,000, the demand is 48. So we are pretty sure that 200 will be left here in node 1 or node number 7. Okay, and then all the requirements for these nodes, these cities will be met, because all in all, their total demand is 4,800, and the total supply is 5,000. Okay, so the objective is, how do we now distribute? Okay, how will the distribution be done so that we can minimize the cost? Because these figures here are cost figures. Okay, so if we read the problem, so this company manufactures expensive luxury cars in Germany, and it exports and sells it to US. The exported cars are shipped from Hamburg to ports in Newark and Jacksonville, Florida. Okay, so ito yun, ano? Newark at saka Jacksonville. So the cars are delivered to these ports, and then from these ports, it will be delivered then to the different ports. Okay, Richmond, or to the different distribution centers. Okay, so which are mentioned here, and this is the possible shipping or trucking route, along with the transportation cost, yung mga cost na to. Currently, 200 cars, so this is, sorry, this should be 2,000. Sorry for the typographical error. So kindly just add zeros there. So 2,000 and 3,000 available in Newark and Jacksonville, respectively. The number of cars needed for Boston is, so, kulang ako ng zero, no? 1,600, 170, 80, 700, 800, 1,600, 17, 800, 700. Okay, so we want to determine the least costly way of transporting cars, definitely, no? From Newark to the different cities. Okay, so this is an example of a network model. Okay, the network model is a lot easier than yung regular LP natin, no? Kasi pag network model, you already have an idea what are your decision variables. Okay, so for the decision variables here, so I think we'll be able to reach just up to the formulation of the LP. What are the decision variables? The decision variables will be, okay, and how many decision variables? As many arcs. Okay, the arcs are the lines connecting the nodes. So how many arcs you have, that's the number of decision variables, because that represents the flow of the items, in this case, cars. Okay, so from Newark, so this is decision variable 1. How many cars should be shipped from Newark up to Boston, and then from Newark up to Richmond, etc. So how many decision variables do we have here? How many? How many decision variables? Okay, 7. All right. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 arcs kasi. 11 arrows, therefore 11 decision variables. Okay, however, 7 refer to the number of constraints. There will be 7 constraints. As many nodes, okay, the number of nodes will be the number of your constraints. The number of arcs will be the number of decision variables. So let's just call it, for the purposes of our discussion, X11. So X11 is the, okay, sorry, X12. So I'm just referring to the nodes. The direction, X12 is the number of cars to be transshipped from 1 up to 2. Okay? So that's easy. That's very easy. If you know the direction, and usually naman, the direction is given. So this is X12, and then we have X14, right? And then from 2, I have X23. Let me just do it numerically, chronologically, X23. And then from 3, I have 3 to 5. Okay, so that's 3 to 5. X3 to 5. And then for 4, okay, from 4, nothing. So everything going inside 4. Okay, and then I go to 5. So we have X53, X54, and then X56. So X53, X54, and then X56. Okay? All right, then how about 6? I'm doing it chronologically so that it will be easy to trace. X, you have X65, just X65. X65. How about 7? Okay, 7 is, oh, sorry. Yeah, no X4, right? X54, okay. We're only looking at the inflows, because when we count the inflows, you're already counting the outflows. Okay, X65 and then X7. X7, 4, 5, 6. X74, X75, and X76. There you go. So how many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 decision variables. Okay, so that's now the decision variables, where X12 referred to the number of cars or number of items to be transshipped from Newark to Boston, etc. So I leave you guys to define this. X12, X14, the number of cars transshipped from Newark to Richmond, etc. So it's very easy to trace this. Okay, next, what will be our objective function? What's our objective function? Okay. What's our objective function? Of course, this is a minimization problem, right? And we're minimizing the cost, right? Okay, so what will it be? Well, of course, you just multiply this is the cost per car. This is just the transshipment cost, okay? It's not the cost of the car. So we're only given the cost of transshipping. So it will be min z, minimize z, which is our total shipping cost. So let me put the shipping cost later. And it will be 300, right, times x11 plus, okay, I won't write everything. I'll leave you to write the rest. 400, multiply that by x14. So pretty straightforward, class. So network modeling is, I say, it's a lot easier than the network, the LP, because this is also LP, but pretty much it's already boxed. The definition of the decision variables or the objective function, it's already boxed. Okay, and then how about what's the next one? X23, that's 500 times x23, a plus, and then let me just let you continue this. And the second to the last is x75. X75 is 450 times x75, and then lastly plus 500 times x776 here. 500 times x76. Okay, so this is our total. That's our total transshipment cost, shipping cost, transportation cost, however you call it. Okay, last will be the constraints. The constraints will be as many nodes. Since there are 7 nodes, then there should be 7 constraints. Okay, so the constraints will take up this form. If the total demand, the total supply is greater than or equal to the total demand, then I need this insert symbol. So we have this, the summation of your inflow, okay? The summation of your inflow minus the summation of your outflow this is inflow minus outflow is, okay, it's also greater than or equal to your total your demand or supply. Okay, take a look at that formula first. Okay. Let's just finish this class, at least next meeting. Where's that? So this is for your constraints. So if the total demand, if the total supply is greater than the total demand, then, okay, let me control, okay, never mind. Control, then the summation of inflow minus the summation of outflow should be equal to your demand or supply. Okay, what does that mean? And how do we implement that? Okay, let me illustrate to you one example. And then for your, this is an assignment that I'll not be collecting. Okay, but I hope you do the, you do the equation already, because we're not going to, we'll just compare the equation. Okay, let me cite to you an example. Take a look at node number 1. Okay. And by the way, first, what's our total supply? Our total supply is 5,000. Our total demand is 4,800. So this first rule will apply. If on the other hand, if the total supply is less than your total demand, then the formula changes. Then this will be less than. Okay, and then lastly, if it's equal, then equal lang. If total demand is equal to total supply, then summation of inflow minus summation of outflow should be equal to the demand or supply. Now take note, the formula is demand or supply because the nodes are either demand or supply. So for example, let's take a look at node number 1. What is the constraint for node number 1? Okay, what will be the constraint for node number 1? So for node number 1, okay, since the total total supply is 5,000, and then the total demand is 4,800, so condition number 1 applies, right? So this will be the rule that we're going to follow. Since total demand is greater than total supply is greater than total demand, then summation of inflow minus summation of outflow will be greater than or equal to the demand or supply. Okay, so for node number 1, that will be, okay, it will be what? So what are the inflows coming here? None, right? No inflows for node number 1, so this should be 0. Okay, and then what are the outflows? Minus the outflows. So the outflows are X12 and the X14. Okay, therefore, for node number 1, let me write it here. Node 1. So the constraint for node 1 is outflows, summation of inflows. So no inflow. Minus, so that will be minus X12. X12. That's an outflow for node 1 minus X14. Okay, should be greater than or equal to. Now this is a supply node, right? So a supply node will always take on a negative number kasi palabas siya negative 5,000. Okay? Oops, sorry. Okay, so, oops. What happened? Okay, so this is the constraint for node number 1. Negative X12, why is it negative? Because the formula is inflow minus outflow. So you subtract all the inflows, then you add all the, subtract all the outflows and add all the inflows. Okay, and it's greater than or equal to, why greater than or equal to? Because the total supply is greater than or equal to the total demand. Then the formula for the constraint is summation of inflow minus summation of outflow is greater than or equal to demand or supply. Okay, now this makes sense because if we're going to multiply this by negative 1, what happens? It will become X12 plus X14. Since we're multiplying by a negative, the sign changes. X12 plus X14 is less than or equal to, this also becomes 5 positive, so 5,000. All right, so that makes sense. It means that what will be going from node 1 to node 2 plus whatever will be going out from node 1 to node 4 should not exceed 5,000, which is correct because they only have 5,000 units. for distribution. All right? So, may I request that you also set up the constraints for the other nodes? So just follow this. This is the rule that will apply because the total supply is 5,000 is greater than the total demand of 4,800. So every node will have to be subjected to this constraint. Okay, and then we now, so that's our constraints. We have your decision variables, we have your objective function, we have the constraints. Then next step is now to create your LP. All right. So as I said, network modeling is a bit straightforward. So if you understand how to get the decision variables, which is just the number of arcs, and the objective function, just follow the arcs, follow the cost or maybe profit components of that, and then the constraint will follow this rule. Okay? All right. Are there any questions? It's okay, it's okay, Carmela. All right. So any questions, class? Sige, walang question. Ano na lang, tanong na lang ako, no? Hingi ako sa inyo ng feedback. I'm going to ask you feedback. How is it so far, our discussion on DEA and this introduction to network modeling? Hello? Absorbing the new things. Data heavy compared to before. Really? Talaga? Okay, sige. That's good. See, anyway, I'll post the video, no? And then request ko, class, make sure that you are able to set up the constraints. It's pretty straightforward kasi you'll just take a look at the inflows. So for example, see node number 4. All of it are inflows. So add x74 plus x54 plus x14, and then minus outflows, no outflows. Okay, no outflows. So it should be greater than or equal to what? 800. So that's the constraint for node 4 because this is a demand node. Okay, if it's a demand node, then it should be plus. If it's a supply node, it should be minus, as far as the constraint is concerned. Okay? All right. Sige. Thank you so much, class. With that, we end
Sir.
our... Yes?
Sir, can I request also to for the past recordings to be uploaded? I think the past 2 sessions.
Past 2 sessions. Hindi pa ba hindi na-upload?
Parang not yet, sir.
Not yet? Oh, sige, sige. I thought I already... Let me check. Modules. March, ay wala pa nga Oh. Okay, sorry, sige. I'll upload the past 2 modules plus this one. Okay, sige.
Thank you, sir.
Okay, and your case class, no? Case, please, there's a deadline for that. That's April 1. 11:59 in the evening. Okay, thank you so much.
Sir, sorry sir. Tanong ko na ulit, di ko alam kung narinig ko kanina sir. Yung mga individual na project sir, kailan yung deadline lang sir?
And then yung case, that's a group. Yung yung sa individual yung sa case yung kayo gagawa. That's
Yes, sir.
April, sabi natin 'di ba? 10.
April 10.
April
Okay,
10,
sir.
oo. April 10.
Okay sir. Meron ba kayong parang suggested na paper format or guidelines?
I can put an outline lang, no? So parang background of the study, ano yung company,
Okay sir.
generally parang ganon, and then yung concerns, yung problem na nakita, diba? Parang case lang siya. Tapos and then you already provide the details about kunyari kung ano yung mga cost, kung may mga revenues concerned ba dyan, And then,
Yes, sir.
after that, mag-LP na.
Okay, sir. Thank you, sir. Apo.
Okay.
Sir, sa Word po ba or Excel yung yung individual na project, sir?
Excel yun.
Excel, sir.
Ah,
Okay. Parang
So, ang
same dun sa
suggestion
mga...
ko, yung facts about the case, okay, sa Word. Tapos yung solution sa Excel mismo.
Okay. Thank you, sir.
Okay, sige.
Sir, required po ba na yung company na pinagtatrabahuan or pwede pong ibang company yung
Pwede ibang
gamitin?
company. Pwede ibang company. Kasi kung wala naman kayo makita dun sa company nyo, pwede iba.
Okay pa. Thank you.
Okay, sige. Thank you.
Yes, sir. Will there be two case study or one case study, one the final program?
Okay, the first case study is the one that I gave you. So you're going to solve that.
Yes, sir.
Okay, and the deadline is April 1. There's another one, case number 2. That one, you'll be the one to create. You'll be the one to write about it, and then solve the LP for that.
Oh. But this one is individual.
The first case is group. So
Okay, yeah.
you're with Zhao, right?
Yes. The second is
The second is individual.
Thank you,
Okay.
sir.
All right. Any more questions? Okay. No more questions?
Done, sir. Thank you, sir.
Okay. Thank you, everyone. Have a nice weekend.
Sir,
hello.
Thanks,
Okay.
sir.
Yes, sir.
Yes. Thank you. Sige.
Sir Bob.
Yes, yes. Sino,
Sir,
Robby?
yes, sir.
Ah.
Sorry.
Hmm.
Message pala, sir. It's a different naman.
Okay.
Yung last meeting, sir, parang may hindi ata
Ayun sa cash flows. Sige,
Opo, sir.
i-PM mo na lang sa akin sa i-message mo sa akin sa Canvas.
Sige po, sir.
Sige.
Thank you, sir.
Okay, sige. Thank you.